Hello, welcome to Introduction to Digital Con Badges. I'm Vortex.
I'm Raster.
I'm Kranos.
I'm NX.
Or watch us get through 104 Google Slides, some were just put together today, in 60 minutes.
Most of them. Let's be honest.
A vast majority of them. So, I'm going to hand it over to...
So there's us.
In reverse order.
Do we stand in front of...
No.
That's me.
Okay.
Well, each interest slide has...
Yeah, we'll get
those.
into our own personal intros in a second. So let's start with Kranos.
Hi, okay, oh cool. Which one's this
That one.
next? That's okay, cool, alright. So, I'm Kranos. I am a Hokkaido wolf, which is kind of like, they're extinct, unfortunately. It's North American gray wolf, except Japanese. I am a graphic designer by day, and I also do IT stuff. And I guess I do it at night too, because I really enjoy doing that. I usually like doing logos and poster design. I love working with electronics, just based on from what I'm here. I also love taking stuff apart, and we'll get to that too. I've been a furry since 2002, but I only started admitting to that in 2007. I made NX a furry. Sorry, not sorry. Which, by the way, both you and you got me started in WoW, so this is really just payback. My first con was Anthrocon in 2006, and things were really different back then. I also really enjoy snowboarding. So this is, can you guys read the screenshots? This is kind of how it all started. One day, Jib Cody, if you know him, he was just kind of thinking out loud. He's like, I was just thinking it would be cool to like make an animated name tag. And surprise conversations in Telegram, and oops, that's not this. Yes. I was kind of really super skeptical about the idea because we started looking and nothing was really good, but it's important to note, let's see. Yeah, I started talking, and the first thing I noted...
right hand.
No, there's an arrow that's invisible, but I'll just point to it. There's an arrow right here.
It's got a laser pointer on it, Clarence.
Oh, cool. All right. Anyway, so there's the line right here that I pointed out. Anything custom would be bulky. They're bulkier than the iPhone, and it had to be custom was my point. And it's possible that the idea could have just died right here. I could have just given up on it right then, but I didn't. And like I said, we started looking, and what we found wasn't good. Everything had like a 2.5-inch-ish display, and the battery life wasn't good. And it really didn't meet either of our expectations out of what we wanted from a con badge. So we set out anyway. So these are the basic tenets of his badge. And he needed to be able to animate it because if it was just a slideshow, that's really not what he's about. And if it was just a bunch of stills, it would be a non-starter. He also had to be able to update it without requiring the Arduino IDE or any special software or being a nerd. He also needed a nice big display, so if you're in fursuit, it has to be want to shut the door?
Yeah.
If you're in fursuit, it kind of has to be oversized to look right. So we decided that we would roughly settle on a 7-inch display, and we also wanted 6 hours of runtime out of it because the thing that I had on the previous slide that lasted an hour and a half, maybe 2 if you're lucky. So we wanted roughly 6 hours of battery life because I thought he'd be in suit 6 hours, but joke's on me. He's in suit 18 hours a day.
Even right now. He's not he's in suit right now.
And it also had to be really durable because I used to table in dealer's den and do con badges. I kind of know what abuses a con badge goes through. So I needed a nice housing that would keep all the innards safe, especially the battery, because I didn't want to set Jib on fire in his first free convention. There's a lot of requirements. It also had to be cheap because there was almost no budget for this thing. It also had to be really cheap and easy to reproduce because I don't have a CNC, I don't have a 3D printer. The only thing I have access to was what I had in my garage and what I had access in my makerspace, and that was a laser cutter. That's not where my things are. It's here. So yeah, I had a lot of stuff to do. I need a better way to.
Do you want me to hold that as a teleprompter for you?
No, it's fine. So this is how we define milestones. what's a milestone? Raster, what's a milestone? It's software development terms.
So milestones help you figure out like the step-by-step of a project. You don't want to have everything come together at the end and find that nothing works. So you want to make sure that like one by one, you're making progress and you can see it happening.
Okay, I wrote it as like it's an important part of planning and it's a mark of progress. So if any one of these steps failed, I would have like had to call it on the project. Like I had to find a 7-inch display, it had to loop video, it had to have a big battery because of the big display, and I had to build a case with tools I had access to myself. So this is the digital photo frame. Really should not have done that in Notepad. So I sourced a 7-inch display. That was the quick. I eventually decided the quickest, cheapest way to get a 7-inch display that loop video was to tear a digital photo frame apart. I think I found that at Amazon or Target. Well, whatever. I could have done something like custom with like from Adafruit or like a Raspberry Pi, but I really didn't have time to do that. So this was the cheapest, easiest way. So I bought it on Amazon. So milestone 2, So I just bought that. It kind of did the job. Milestone 2, I need to find a way to run the photo frame off of a battery. The photo frame had to be modified, so because most of the stuff I usually do, it runs off of 12 volt or 5 volt. It's always powered off of the wall. It's kind of the first time I worked on something that required a battery. And it's also at this point I also had to start thinking about the size of the battery and how large I wanted the battery. I decided that 18650s, like the cylindrical lithium-ion cells, those wouldn't cut it. I had to go with the like flat pack lithium-ion or lithium polymer battery. Also in this particular slide, I was kind of measuring. I was projecting how long the battery will last. I initially started with a 1.5 amp hour battery. That lasted maybe 2 hours, and I did a whole bunch of measuring and math and decided like a 6 amp hour battery, that would do it. That would give me about 6 hours battery life. And as I ran it, it turns out I got almost 7.5 hours of battery, and I was very excited about that. And I told him about it on Telegram. So once I got the thing to loop video, and once I was really happy with battery performance, the next part was actually the majority of the work. I didn't have access to the 3D printer that worked. The Makerspace did have one. It was small. It didn't work. I also didn't have access to a CNC, but the Makerspace had a laser cutter, and laser cutters use vectors. And because my background is in graphic design, I can draw vectors all day. And if I fed the laser cutter a vector file that I drew in Illustrator, I could cut it, and that was all great. And so I decided that a stacked acrylic case is what I would use for constructing the case. And the little hexagons I put in, it looks like it saves weight. It is debatable if it saves weight or not. I just like how they look, and I just need a place to kill space.
You're supposed to say, it saves weight completely. That's a design feature.
Yeah. By the way,
you say it with more conviction.
Yeah.
Yeah.
By the way, this was all like 2 years ago, so if I missed anything, feel free to jump in. So let's see. I've never worked with a laser cutter, so I'm jumping ahead. Did I?
No, you're good.
No, I'm good. Okay. I never worked with a laser cutter, so I kind of prepared myself for ample amounts of screw-ups, and I made a whole ton of waste. But in this particular slide, let's see. Just measuring the components to make sure they all fit. And there was a lot of remeasuring and a lot of double-checking the work to make sure they fit the acrylic case. Do I need to not do that? Yeah, okay. I kind of jumped ahead, but after a lot of measuring, and finally ended up with, I cut in the clear acrylic first because the clear acrylic's cheap, and I made it, and the photo you see right there, that's the first prototype, something that actually resembled the final product of the case I actually really wanted. And we kind of ran into a new problem. I had spent so much energy designing the case and all the insides, I hadn't really thought about how he would actually wear it. Most lanyards are kind of thin, and they don't really clear fursuit heads. That's kind of the problem with most lanyards. They're also not comfortable to wear, especially the real thin straps. They kind of cut into your neck, and they're also really not comfortable if you have something heavy hanging off of it. So the strap had to be comfortable. It had to be comfortable with something heavy on it, and it had to clear fursuit head. And what I eventually decided on was DSLR camera straps, which there's a couple. Here's one here. So, what? Shouldn't have done that.
Durable.
Yeah, that one's durable. DSL camera straps, they're designed for heavy loads. They come in all sorts of colors, and great, they're also available on Amazon. The case design was immediately modified. Like, I just put the little holes at the top, and I just put it on my wolf plush, and it seemed to work out well.
Furry.
Yeah, guilty as charged. And with with barely a week between Thanksgiving and MFF, it was time to like actually cut the real acrylic. He wanted orange, so I went with orange acrylic. At this point, I had addressed all the problems, so I was pretty confident it would be pretty smooth here on out. And then that's more construction photos. Yeah, I work on my kitchen table. I live in a semi-small apartment. There's not really a whole lot of room to work. But by the way, if anyone has any questions, like feel free to raise your hand, and that's the final construction.
And for the border art, did you have orange and then like a clear layer?
I mean this stuff right here. So what it actually is so there's a clear acrylic, and right behind it, it's artwork, and it's printed, it's laminated, and it's artwork he provided. I gave him like a little template. And then he drew on it, I printed it, and I just sandwiched it between the front layer of the mid-frame and then the front acrylic. And then, it could take a beating. It's taken many beatings over its time. But it eventually did break. Let's see.
Oh, that's right.
I skipped all that. Almost a year later, it met its match at Furpocalypse 2018. I kind of expected it to break, like, at MFF instead of... Like, I really didn't... Like, it was kind of an unproven design. I didn't really know how well it would survive a FurryCon. But I expected it to get damaged at, like, a rave or, like, in a fur pile or just, like, getting stuck into an elevator door. Like, my badge got stuck in an elevator door. But what actually happened was it fell off a table, and that's what happened. What I actually think happened was... Like, all the years he's been wearing at FurCons, like, the acrylic was probably developing all these little microfractures from all the stresses, and it was the fall off the table that finally did it in. But the case actually did do its job. Like, none of the internals were damaged. I just swapped it out for a new case, and he was good to go again. Things I learned the hard way. I made a lot of waste acrylic, which it's not really waste because I can make, like, keychains and stuff out of it, so I still have a lot of scrap acrylic. But this second one's real dangerous. Like, not the battery connectors and the hardware you buy, the polarity of those things aren't really standardized, and things could have gotten really hairy if I had not been careful. Like, I even drew myself a diagram on which side was the positive and which side was the negative, but some stuff ships the other way, and so I just had to, like, standardize on one type of connector and make sure everything was wired that way, otherwise I might blow up some boards. But after I built that board, or after I built that badge, these guys started making badges. But I didn't really have one for myself. I built Jib Cody a badge, but I didn't have one for me. So, and I happen to have like I had an e-ink panel like just in my junk bin for like another project that never ended up happening. So I quickly got to work in Illustrator and had this drawn out, which was heavily based off of the one I built earlier. I started on this like a week. Like it was the Tuesday before AnthroCon.
5 days.
Yeah, I kicked it out 5 days.
5
But
days.
I want to mention that was only possible because of all the things I learned building the first badge.
You get better at it.
Oh yeah. I hastily ordered everything. I ordered a new battery on Adafruit. Like I'd done all the battery calculations for the other badge, so I kind of knew like all the math I needed to do to calculate battery life on the second badge. So I bought an appropriate size battery, and luckily it worked out. I ordered and the charge controller from Adafruit, and I bought acrylic sheeting from Amazon because acrylic sheeting usually ships in like it ships on a pallet. It's not easy to handle.
Usually 4x8 sheets are
Right,
standard. Yeah,
right. And my laser cutter I have access to at the makerspace does not fit that. So I order my acrylic sheeting from Amazon in like 1 foot by 1 foot sheets, and that's great because I'm not making a batch that big. I also had to. So the first badge required 0 code because it's literally just a photo frame ripped apart and rehoused. I had to relearn C++ because the e-ink badge, it's an Arduino compatible microcontroller. So I had to relearn C++ to write code in again, and it crashed a lot. It kind of still does, and there's a picture of a fun crash. I still haven't really figured it out. And there's a number of problems with the code. It mostly works. So this was the process of making that e-ink panel actually do its job. The first one, it just produced a whole lot of garbage, and the documentation wasn't great, so I had to kind of figure out, like, fortunately, the people who made the e-ink panels provided a lot of source code, so I had to dig through that, and eventually I was able to kind of see a nose. I'm like, well, I'm getting somewhere. And it turned out, I kind of see the nose in the center. It turned out that I had like the X and Y reversed. And eventually I got that, which is pretty much the image I wanted, except it was inverted. And that's easy to do in Photoshop. So I started cutting out the case after all the stuff arrived. Just kind of fit testing everything. There's a little sticky note for the battery, because I don't actually want to fit test with the real battery in case I puncture it or damage it. So little sticky note to substitute for the battery. And what are you making faces for?
Keep going.
All right. Do you have something to say?
No,
Like,
I've done that. Just keep going.
Okay. Also, the other reason why this design was so quick, like it only has 4 layers of acrylic. This had 7, so it was half the layers, so it's half the things that could go wrong, and for that reason, it also went quick as well. And doing some more fit testing, and that is completion. Now more or less completes my badge.
Yeah, next slide.
Oh, I do have one more slide. Yeah, so what's next? I forgot about this part. So one thing I've noticed with this particular badge, people want to see it. The only way for me to actually get it to display a new image on demand is to turn it off and turn it back on again. Like, I had to reboot the badge for it to actually do something. Otherwise, like, it draws a new image every 30 seconds. So probably some fun way to get it to refresh the image. Like, I was thinking, like, you like shake it like an Etch-a-Sketch and it draws a new image.
Why don't you punch it?
I can't do that. I already do that normally. And something, maybe a microcontroller like less crashy than the one I'm using. I'd been suggested an STM32 or a TI MSP430. Is it TI that makes it? All right, good. I know who to point to now.
Yeah.
I had to find a way to make adding images easier, because currently you had to take the image, convert it to like a byte array, and then compile it in the Arduino IDE, and then reflash the Arduino, which is actually, the program port's buried inside, so I had to take the badge apart. I needed an easier way to, like, reprogram the badge without taking it apart, and also if other people are interested in it as well.
Yeah, none of these are plug and play. So
right. All these badges are kind of designed with the person that built it in mind. Like, I'm perfectly okay taking it apart because I built it. And as far as this particular badge, I'm probably going to base it on a Raspberry Pi now that I have the housing more or less figured out. Maybe for some like interactivity. I might be kind of done with doing stacked acrylic because there's so many layers to manage. I might do something 3D printed, because I actually do have a 3D printer that works now at my makerspace. And one thing that Jib had specifically mentioned was there's these little tiny little switches that are not easy to flip if you have fursuit pobs. Yeah, so he specifically requested a push button start. And that I hand it over to. Yeah, there you go.
Okay.
Oh, before I do, was there? Yes.
Seeing as a lot of screens use like ribbon cables,
Uh-huh.
how do you connect a ribbon cable to, say, like a Raspberry Pi or some other type of like electronic circuit if it hasn't already been like connected to it originally?
Oh, so the question is like, how do I?
Like with the e-ink screen.
The ink screen actually has a ribbon coming out of it, and the company that made the e-ink screen also ships a daughter board that kind of breaks the e-ink, that tiny little ribbon cable out into jumpers or little more solderable pins. But in my particular case, the company that made the e-ink screen also made the Arduino compatible controller, which crashed a lot, so I might stop using it. So I probably will have to resort to using like a daughter board or a little breakout board like that.
All right.
But yeah, connectors and cables are easily one of the things that take up a lot of room in that thing, because you can't really manage them and manage all those cables and keep the chassis thin as well.
And
ribbon
batteries.
cables aren't exactly strong.
No. Also to mention, those ribbon cables are fragile. I've tore a couple, just like kind of
I think we all
maneuvering
did.
them. Yeah.
I've soldered a couple.
Anything else?
All right.
There you go.
Okay. So, hi, I'm Vortex. I'm a Coyote when I want to be. I'm a head-end engineer for a local regional cable company in southeast United States. So please don't hate me because I'm a cable engineer. I don't try to make your service bad. I try to fix it. I studied industrial technology in college. So not exactly EE, but it had an EE focus. I never actually finished it, so I got started in the cable industry and stopped going to school. So I'm hoping to go back eventually. I love the maker movement and the DIY movement. It's important to me that that all this information's out there. Back when I was growing up, this didn't exist. Raspberry Pis, Arduinos, the internet as itself wasn't around as much as it is now. So it's really cool to see it kind of grow and have all these people here listen to us talk.
It was all basic stamp back then.
Yeah, basic stamp was a big thing. Pick stamp or picks were big too. So also, this is my first year in the fandom. I'm gonna April 20th is my first day. Also, also for all of us here, it's our first panel.
Nice.
So this is pretty crazy. Thank you all for coming so much. So, what inspired me to do this? Him. I actually got inspired a lot by, you see a badge down here, it's the DC Furs badge, but there's a hacker convention, a hacker gathering called DEF CON. And DEF CON every year has these challenge badges that are microcontrollers and LEDs and displays, and they have challenges you go into and you try to figure out what's it doing, how do you get to the end goal, and the ultimate goal is to get what they call an Uber badge. And that is the winning badge if you complete all the challenges. And even this year, they had 8 different badges. You had to talk to everyone who did have one of the other badges to win the challenge. I kind of want to do that myself. We have a group of friends that every year got together and had a LAN party. And I'm like, this would be so cool just to do something simple for these guys to try to do that. And I started talking to him about it, and he's like, well, look at this thing that some furry artist I'm making for. He makes good animations. And I was like, that's really cool. It gave me a reason to actually play with these RGB LED displays I've seen. So I joined the fandom. I realized about a year ago that I really needed something to be more subjective as opposed to objective, because my job went from being pretty simplistic to being very complex all of a sudden, and I needed something to take my mind off a bit. So I wanted to start building a badge. So what did I do? I started a YouTube channel. That's the wrong thing to do. But the reason I really did it was because I learned so much from YouTube, and I learned so much from people who actually put their information out there and do presentations like this and do talks like this, that it was really important for me to do that do that for my projects, because I also didn't see a lot of here's all the steps I've taken to do this. Here's the initial design. Here is the failures I've had. Here's this step. Even though it may not appeal to everyone, I thought it was important to put it out there. I still do ROM Labs. I've got about almost 100 subscribers, 98 as a count as today. I haven't actually done a video in 5 months because I've been that busy. And it's been a great way to learn subjectivity, because I'm putting about 15, 16 hours into one episode between recording and editing it. So it's really important to have something that's like, okay, I need to let this go and finish it, otherwise it's never going to get done. So when I actually started, NX has a badge that he'll talk about later that actually has a much bigger display than what we have here. And I found the smaller display that you see on the table now on the far left that's bright, that doesn't have a badge around it for reasons I'll get to later. And I really wanted to play with that. It was something that limited me, and it was, thank you. It was something that was limiting. It had it's 32 pixels by 64 pixels, and it's a pretty. I'm going to use the term open standard. It's not really open as much as it's well understood. I also had I didn't have great access to a lot of things. I didn't have a 3D printer. I didn't have a CNC machine at the time. But I did have a decent makerspace, so I wanted to make sure I had a case that could design. I had resources. Excuse me. I wanted to design a case with the resources I had, or at least I thought I did. I also really wanted to do a clear separation between the hardware and the software. My goal, I come from more of a software background and a server background, so I kind of wanted the software to stand alone and be something I could take to other badges and say, okay, let's simplify everything on the software side, that it runs on a Raspberry Pi and it has a web interface. You don't need to worry about switches or buttons and stuff like that then if it works like that. And I also want to use as a test bed for future work. So really important is when you start designing something like this, you start a project like this, you have to kind of figure out what you have access to. For me, I actually had a makerspace. I had a makerspace. They decided, they kind of got kicked out of their space, and they were like, okay, we're going to move. And that was a year and a half ago, and we're still in the process of finding a space. I don't know if it's ever going to open again. But the neat part is I started mentoring a robotics team that I walked into and had a Tormach 770 mill. So I had access to a CNC mill. So I know how to use CNCs because I've watched YouTube and watched a gentleman by the name of John on NYC CNC. He showed me how to do it. I figured, why not try that? So look at what other resources you have available. Local schools or local community colleges. Sometimes they even have classes that teach you how to do this as night schools. Find local friends or get online. Find people who might have the resources you can do. One neat thing that I get to do is I actually volunteer for a high school robotics competition called FIRST. And the team I mentor has a relatively decent workshop, like that Tormach 770 I mentioned. They weren't actually even using it that well. They had bought it as part of a way to teach the kids G-code and some basic milling, and they were using it for metal and, they're using it for wax and wood. And I walked in and talked to the teacher. I'm like, you guys realize this does aluminum, right? No. Well, yeah, look, it does all this stuff. Really? So I actually was able to teach them how to do it. These are actually my first 3 parts. So all the way over to the left, the black little circle, that is a 3D printed encoder mount for a robot. I first milled it out of wax, and I milled it out of aluminum. And that was my first 3D milled part on that particular machine. So the one thing I learned quickly is I personally use Fusion 360 to do my mockups and design, and you need to take projects really slow and multiple steps. Solve the bigger problems first. How are you going to power the thing? What display are you going to use? Those are going to help you further to your design later on. In programming, the term is called fail fast. So if you find something big, you fix it early on so you don't find it later and it fail. So even pen and paper can help you. I'm going to get into it in a second, but one thing I found is even resources like McMaster-Carr. Does anyone know what McMaster-Carr is? Okay, got confused. McMaster-Carr is like a hardware store on steroids. They have just about any screw, nut, bolt, latch, gizmo you could find. Washers. Anything you can find is on McMaster-Carr. If you can't, they can probably get it for you.
Paper manuals like that thick.
Yes.
Or the paper catalog.
Yeah, it's huge.
Make sure you're not getting left-hand thread.
Yes. It is that accurate. So you can use that as a resource to go, okay, I kind of need this. The other thing I've done is I've walked down the aisle in a hardware store and like, what works? I did that for this because I need to figure out screw size. And I'm like, well, I can't really visualize what a 440 screw is. So I walked down and I'm like, okay, so this is a 1/4 inch and this is smaller. And so I kind of figured out what size I needed from there. So let's talk about that screw size. The rest of the badges here, for the most part, use something called a sex bolt. And this is an 80 panel. It's not that kind of sex bolt. It's not 80 panel. It's actually a bolt that fits into itself. The problem for my design was that even the low-profile heads on it were 13/32, which is 0.046 inches, so almost a 1/2 inch. That means I'm adding almost an inch to my bezel just to support it. That didn't really sit well with me for what I was going for. So what I ended up doing was looking at what I was my design. I was going to mill the badge out of aluminum because I had access to a CNC mill. Well, could I tap the aluminum? Well, yeah, it seemed like it would work really well. So I decided to try that, and I was able to use a screw that ended up. I have a 1/4 inch rim on my design that I tap into. So by that, I was able to save an inch on my design overall. But how do you attach a strap to it? I actually need to wear the badge.
So you thought about this before I did.
Well, because of the people I talked to, I thought about it, and well, so I wanted to be able to put the I want to be able to wear it in 2 different. Oh, what did I do? It didn't shut off. Okay, good. Okay, So if you look here, this is the one of the mid designs of my badge frame. I have these slots on both the portrait and landscape because I want to wear it both ways. So I needed to somehow get stuck in there. So I ended up using a dowel pin. I use about 1/4 inch on each side and have a 1/2 inch slot. So it lets me attach a strap by just wrapping it around the pin. But I'm still not kind of done with this issue yet because what if the pin turns or what if the pin moves in the slot? And also it kind of leaves some big ugly holes. So we're going to see what happens as I kind of work on that design later on. This is the current design. This is everything milled out in Fusion 360. So I have a space for the display. And what I actually did in Fusion is I built the display in Fusion, just using some rough estimates so I knew how to build it. I have a spot for the battery. I have some spots for the Raspberry Pi and the bonnet I have up here. And I'm going to mill it eventually. Where's it at right now? It's still raw aluminum on my desk at home. Actually, the raw block is 2.5 pounds. The Fusion says it should be about under a pound when it's done. The robotics team I mentor, I'm cutting a lot of aluminum out of this thing. The initial mill time when I first did this was about 2 hours until I started optimizing feeds and speeds. The robotics team I mentored when I was going to do this, it was spring break, and I lost access to the mill for that week, and that put me behind. I do have plans to get finished for FWA, assuming nothing goes wrong, and let's be honest, it probably will. And I hope to have better software too, because I'm still using the default API that comes with the bonnet. So this is my Mark 1 badge. This is kind of my first design. I really, really like OLED displays, and I want to play with them, but there's some interesting challenges that come with them. There is the kind of like the display that's on a cell phone. It's called a MIPI, M-I-P-I interface, and it's 40 pins, and it's SMD, and it requires a lot more design work that I can put into it, but that's something I'm going to use to learn PCB design and learn more electronics design. It's also a lot less hungry than an RGB display. The RGB displays that the Pixel ones we use at max brightness with all white will draw about 4 amps, which is not very practical for a badge design.
20 watts.
Huh?
Is that 20 watts?
No, 4 amps. 5 volts at 4 amps.
20 watts.
20 watts.
20 watts. 20 watts. Sorry.
20 watts.
Question.
It's question?
They
Yeah.
also burn, don't they? OLED.
OLEDs. I think there's a burn-in.
If you're careful with it,
Yeah.
you can kind of mitigate it.
So it's something I'm gonna have to consider.
Yeah,
Yeah.
because usually the buttons at the bottom, they
Yeah.
like get burned in, right? Yeah.
Yeah, and it's something I'm gonna have to think about too. I mean, I'm gonna have to cycle display more. I'm doing animated GIFs on mine, so maybe push back there. Or, yeah. Also, like everyone else, I'm considering alternate forms of microcontrollers or FPGAs. I found that the Raspberry Pi Zero is interesting for what it does, but it's definitely not practical for a badge design. I'm wondering if maybe we could pair it with something else to kind of do the software server side and use
Oh, good.
and use the do the heavy lifting on something else. So, and I'm gonna hand it over to Raster.
Thank you. So I'm a Texas local. I'm a Wolf. I'm also a software engineer and a game developer. So my thing and the reason I want to do this is because I felt like I needed a creative outlet. I joined the fandom like a year and a half ago. And it's a very creative fandom. Like you see these guys and you see everybody just drawing and making awesome art, which is not a talent that I really wanted to pursue. I really wanted to do, my way of getting back to the fandom was the badge. So I started thinking about what it takes to build this thing. Like, I only know software. I have no idea of hardware. Like these guys I've been talking to, they can throw out microcontroller names, they can throw out designs, and all I know how to use is a pen and paper and C. This is it. So I start from absolutely no hardware experience. And what I wanted to do was same thing. I wanted to have some goals, like set some goals for yourself. I wanted to have a badge I can hang around my neck. I can show off to people. I wanted to have an image on it. Nothing too crazy. Just like set a first step. The first iteration. You don't want to do something like I want to connect to the internet and do download images and all this stuff. It can be a very rough thing. Don't bite off more than you can chew in the first iteration. And then to the races. Nope, break it down. I'm just gonna be large. Break it up. The first thing I did was literally like look at screens, look at a Raspberry Pi, put them together, and connected it to the wall. This is on my desk. Like, this is what you need. Like, fail fast. Does this even work? Can I even connect two things together? Can I even connect this ribbon cable to that ribbon cable? You don't even have to like write all these steps down, but you just have to think about what's gonna, and you have to anticipate what's gonna come up. And that's it. That is the first prototype. Like, you just see, that is just a screen on my desk connected to the wall. And seeing this, it helps you. It helps you think about, like, it motivates you. You see the thing working. You see the end result. You can get excited about it. A lot of times when you do big steps, you start losing interest. You start saying, like, oh, this is going to take me a month to do. And then you're working on it for 2.5 weeks and you start slowing down. So if you take small steps and you can see it happening, it keeps your motivation up. So that is the limit of what I could do. I really did not know how to do anything else with hardware, hardly knew anything, and I was going to learn how to solder. Oh boy. This was the first attempt. These things are they're very friendly even. This is like the learn how to solder. It's like $2 in fries. First off, I raised a trace. It was ridiculous. Like, you would move the thing around and the trace would just start moving up and down. That caught fire. That over here, like over here on top, over here, that also caught fire. That guy was pretty good. You know, that was the last one. You know, it's pretty good. But you know what? It worked. You know, so like, I don't care that it looked like that. Like, that is a result that I'm happy with. That thing worked and it served its purpose. So don't feel like, if you start seeing that stuff is going wrong, don't worry about it. If it works in the end, you get better at it. And this is a result. Like, this is one of what is called a charge controller. So this was powers the battery on most of these guys.
All of them. Those things are fantastic. The power boosts.
Power boosts are
all of us use these things. They're amazing. They're like
amazing.
$10.
They also almost catch fire. They're really hot.
Yes.
You have that too.
And like, yeah, so like, I literally started putting things together. Like, this is the version 1. Just stage it. Note that in my badge goals, case was not one of them. This thing, the case was hand cut acrylic, which it took its price in blood, and I just hung it around my neck, and it just had a simple panel in the back. But hey, it worked. This was what I presented in AC of last year. It's somewhere here dissected because its parts were used on better projects. And you know, it's fine. And once the project is done, you can have unintended consequences. I glow blue in raves. It's red when by the end of the night because the battery's dying. Yeah. And then you have to think about what did it do what it wanted. So you have to start once you start doing these steps, you have to start thinking about, does this work? Does what worked? What did it? Always be critical of your work. Always think back about what you can do different, what you want to do better, but don't take it personally. Always take your ego out of it, because a lot of people will think about the ways that this can look bad, and it can hurt your self-esteem. It can hurt your motivation. Don't take it personally. Like, this guy is like, this screw is just bent. This is completely like, you can see this thing is just like one curve all the way up. It cut me many times, but hey, so don't worry about it being perfect the first time. Perfection is the enemy to getting a project done. So, and the second version, I really wanted to make the thing have a real case. I wanted a bigger screen. Like, it's not really fursuit size. The fursuits are larger than life, and you have to think about the application. You really want to see it in person. And I really wanted to work with a laser cutter because those things look neat. Like, honestly, take your time to learn these things. Like, one of the things you can do is always incorporate something that you can learn into these steps. the first step I want to learn to solder. So once you get used to it, you get better at it. And then the second step, I wanted to learn how to use a laser cutter. There's tons of resources online, YouTube. You can look at, if you live up in Frisco, the library does classes on it twice a month. It's just like that. And your makerspace, anywhere that you can, they can help you. And as a result, I have some demos here after, and you can see how these things get put together. You can see more or less how this starts stacking. Like I designed this on paper, and then I designed it on a vector program. That's another thing I learned. After I learned that, I learned how to do a vector. Designing on paper is actually kind of helpful because you see a lot of problems. Also, the reason that there are multiple is because measure twice, cut once. And also play with what you have. Like once you're kind of happy with it, you can branch out a bit. Like these things have a fair amount of power, and they have like GPIO if you want to connect with another device. Like for example, the screen you can control the brightness on it. And so I started up a couple wires and just started playing with it. So always play with what you have. Like these things have more capability than normal. So just be aware of it. So one of the things it does have is like in this case it has like a GPU. So you can actually like do image effects on it. So this goes into modes where it'll just add images and it'll do like a chromatic aberration. It'll do distortion. It'll look like a pastel or like a hand drawn and notebook drawing. So these are like fun little things to add to your badge. It's like make it interactive because a lot of people think that if it looks like a still image, it doesn't really show. So I like to add the interactivity to it. For example, like mine actually boots, so you can go there and you can actually see and you can boot his nose. So it's cool stuff. So you have to add a bit of yourself to it as well. That's a good way to put it. Also, on the software side, make sure you always don't test on the badge. The badge is your final product. If you want to make sure that this thing works, make sure it works on your PC. How many developers do we have here? People that know how to write code. Okay, so we have a fair amount. A lot of nerds. Make sure like your environment works. Also, this is simple code. If you don't know how to write code, you can probably learn. It's not hard.
It's a great project to learn on.
It's a great project to learn on. Keeps your motivation high. But yeah, just make sure it works on PC because debugging on these things is not easy. Yeah, just do it live. Do it live. Very true. And here. Oh, sorry.
Hi, it's my turn now. Hi, I'm NX. I'm a fox on the internet, a human in real life, I guess. That's what I look like if you see me in suit somewhere around here. I am a fox on the internet. I work in IT, but I do not code. I am not an artist. I have no hardware experience, but I know how to use a soldering iron. That's the one thing I know how to do. So here we are. I like to read PowerPoint slides verbatim to an audience, so buckle up because it's that one of those presentations. So, okay. Why am I doing this? It's your fault. Yeah, it's this whole
he is the patient zero for me and NX.
Stupid badge is the reason all of us are doing it. But these things they're very much a furry thing, right? It's a creative outlet. It requires you to use different parts of your brain to kind of figure out and solve problems that you come up with. And I wish I could have done this as a kid. You know, like I think you were talking about. All of us were talking about it. Like this. I'm 33 years old, and so we didn't have any of this stuff when I was a kid. You know, when I was a kid, we had if you remember Logo on the Commodore 64, like driving a little turtle around. That was like as advanced as it got. And as frustrating as it is, it's a lot of fun. So my takeaways from this whole experience are things that pretty much all of us have been repeating the whole time. Failure is always an option. At least I will always learn more from a failure than I will from doing something correctly the first time. Because you can just follow a tutorial, but did you really learn a whole lot? Or if it falls apart after following the tutorial and then you figure out how to make it work, well, you just learned a whole lot about how to make it go. Learn to use the tools that you have. These guys kind of like were very like they actually thought about what they were doing before they started doing this. I just rushed into it head first, so it was just like stuff that I had lying around. That's what I'm gonna make my badge out of, and it's a lot of fun. So, I got started. We've been talking a while about Jib Cody's badge, and I'm wandering through the aisles of Micro Center. I live in Chicago, so we have a bunch of Micro Centers. It's like Fry's or any other just like computer. Okay, great. And I see this thing. It's a 16 by 32 pixel RGB. It's the kind that Dex has. It's sort of what's right here. It's these sign modules that if you see like a digital billboard, they're just these modular things. Like you pull it out, plunk the new one in, and it's brighter than the surface of the sun. Like this one's running full brightness. And so I picked one up. And since it's a Adafruit product, they give you a whole bunch of documentation about here's how to drive this thing, here's how to run video or run pictures to it. It included an Arduino library to do some kind of simple stuff with it. So I just said all that stuff. It says Hub 75 standard. It means you can like plug a whole bunch of these things together. It runs on 5 volts. An Arduino can drive it. It can run still images. It doesn't really have a whole lot of power. It's really super bright. And yeah, so the original plan for my first badge was very much like what Kranos did with Jibs and Raster did with his, is I was going to laser cut a whole bunch of acrylic and just stack them together. And that's fine. Like, there's nothing wrong with that. It works really well. Before I started going into this, I think very two-dimensionally. So, like, we're making three-dimensional products, and if you haven't worked in 3 dimensions before, well, a 3D printer just takes a bunch of 2D slices and stacks them up, right? So that's what we're doing with acrylic. So, great, I'll do that. Well, it didn't work. You probably guessed it because I wouldn't have written that's the original plan. This was the very, very, very first version of my badge. A thing that I found, you can kind of see in here, what's the laser?
Big center button.
Right here, like this display. The actual display is probably the size of this entire badge. The thing's massive. And it kind of like stuck an Arduino Nano in there with a really bad solder job hooking into the video input for it, and kind of laser cut a whole bunch of layers. I had 5 or 6 layers of 1/8" acrylic stacked together, and then screws and bolts. It was really nasty, but it's what I had lying around. Here it is in action. That's literally the only thing that it did, because the Arduino does not have very much power. And up there is it being cut in the laser cutter at my makerspace. I think I'm very fortunate that I have a very, very large laser cutter at my disposal. So, like, I had one of those huge acrylic sheets and just throw the thing in. I had to cut out like 4 or 5 because I knew I would break them. And I broke them. Acrylic is very fragile. You can see I got these real, like, they look great. I got these sharp corners, but you also see there's not a whole lot between the corner and the edge there. So you so much as look at that acrylic funny and it just snaps in half. Whoops. It just snaps in half. There were a bunch of times where I would pull the piece of acrylic out of the laser cutter and like, it has this adhesive film on both sides of it. And you'd peel the adhesive film, and it would peel the adhesive film and snap a corner off before I even started using it. So that is the failure for that one, and that is why I did not do that. And learn to use the tools that you have. Well, right around the time that I started making terrible badges, I also I started to learn the 3D printer that I had. So you can see everything up here that I've made is 3D printed. So that's when I started using the 3D printer. Now, I didn't know how to design anything in 3D. So again, I was working with making Illustrator files and then just extruding them to make them 3D. So you can see, well, maybe you can't, but I have a whole bunch of layers. Like, I still have my clear acrylic in the back, but I started just making little individual pieces and kind of putting them together, gluing them together, and stacking them up on top. So it's still the same idea, but it's with 3D printed plastic, which is way more durable than acrylic is, and I wound up with a functional badge that didn't break apart all the time. And in the same way that Kranos started using DSLR straps, I got a little DSLR camera strap over there. You got to pay attention when you order on Amazon, though, because the first one, the strap was so long it hung down to here, so I had to have like zip ties on the back to hold it up. So, why did I give up on this? Well, those Adafruit Power Boosts I was talking about, they're great. They take the 3.7 lithium-ion battery, 3.7 volt lithium-ion batteries, step it up to 5 volts that all of our stuff uses. Well, the first version, I just used those round 18650 cells, are the ones you see in like vapes and stuff. It's hard to tell what polarity it is, and if you plug it in backwards, you let the magic smoke out. This is the little power chip, and that hole right there, that's where the magic smoke came out. Oops. And Arduinos are not powerful at all. You can't play video. What you were looking at was it like stacking 16 still images on top of each other, and then just like moving the text. It was real bad. Like I'm embarrassed by that code. And Anthrocon was hard on it. I physically broke it. The battery exploded. Like it was a bad time. So version 2. I got home from Anthrocon. I immediately pulled that stupid thing apart. It's in a box under the bed somewhere. I think some of the pieces are in here. I don't even know where it went. So what do I want to do this time? Well, I had good luck with 3D printing. So these versions are going to be all 3D printed. The chassis is going to be totally 3D printed. I want to make it smaller because the picture I wish was in there is not in there. This thing was huge.
I mean, literally, it was. He had. This is the second version, right?
Yeah.
Okay. He had. It was the same size as this display. This whole badge, that was the screen size plus badge around it.
Yeah. So it's probably more a footprint of this, except wider, and it had a battery life of maybe an hour because these displays running full tilt are a couple amps, and it's not good. So I want a better battery life. I want to be able to go more than an hour on a charge. So better battery and higher display resolution. 16 by 32 is like. The Atari does better than that, so I'm going to do that. So, for better battery life, yes.
How long do they take to charge?
This thing, it charges at about an amp, so depending on the size battery, 4 hours or so. Like if I wear it to a rave or something, and it's completely dead, I plug it in, by the morning it's fully charged again. I've never actually timed it, so, not too long. So the battery life for these guys, I'm going to use those flat-pack lithium-ion batteries with a power boost, with a USB port inside. It's real easy. And I wanted a high-resolution display, but I already knew how to work with these displays here. So I went to eBay, and they had 32 by 64 pixel versions of them, which are, it's the same size, just twice the resolution. I had to have art specifically commissioned to fit this resolution because otherwise, like, if you just take a 1,000 by 1,000 pixel thing and cram it down to a display that small, it's unintelligible. It looks like a mess. I wanted to put a Raspberry Pi Zero in there because I wanted to be able to drive video, like I sort of am now. And there's lots and lots and lots of hot glue. The whole thing. My second version, I didn't know how to use screws yet, so I just hot glued everything, which don't do that. So, like I was saying before, I don't know how to 3D model. I know how to use Illustrator. So I found this website called Tinkercad. With Tinkercad, you can feed it a vector file, and it will let you extrude out your 2D thing into a 3D thing. And then you can print it. Well, so basically what I wound up doing was going into Illustrator and like laying out all my layers of stuff, and then stacking it up in Tinkercad, and exporting it out to an STL file, printing it on my printer. And I went through a lot of iterations of this. Like, the cool thing about having a 3D printer is that you feel less scared of messing it up, because if you mess it up, you just throw it out and do it again. So this is probably the 15th time I printed this stupid badge. And I finally got it right. Like, it finally looks good. The plastic I was using is not the most durable because it's falling apart, but, you'll learn as you go. So, failure is always an option. The battery endurance is still a challenge because I had kind of a tiny battery in here. What am I talking about? That slide is in the wrong place. Anyways, my problems with this one were the display was still not a resolution that I liked, and going as far as learning with the tools that you have, I know how to use Illustrator. Going into Tinkercad is not ideal, but it's what I had. I was able to make it work, so like, that's fine. So, after seeing Raster's badge, where he had the touch to boop, I wanted a touch to boop, and Adafruit had it's this piece of plastic that you can turn into a capacitive touchscreen. Capacitive touchscreens are really hard. Like they make it seem easy. It's really hard. So I'll just let that one go. You basically, if I got to about 6 inches away from the screen, I thought I was touching it. So I just, I also I put dark plastic in front of it to dim the screen a little bit. So I had to turn the brightness all the way up, which means the power boost got too hot after about half an hour and would just start rebooting. So I think I threw that one in the trash. Like, just the whole thing. I didn't want it anymore. So, NX version 2.3 is literally, well, that's actually what this one is. This is the original version 2, but I tried to put in wireless charging because I don't like ports sticking out the side of things. Wireless charging is also hard. So if you know any engineers who work on wireless charging, thank them, because it's not easy. Like, there's a wireless charging coil you can buy to stick in there, plug in the power boost, and it sounds a lot easier than it actually is. And it's still very low resolution. I want to show video files. So I move on to version 3. Oh, yeah. So I was in a panel about an hour ago, and I should have been paying attention, but I put this slide in instead. Learn when to declare it good enough. I had iterated on version 2 so many times that I was just like, I wouldn't even finish one version before, like, while the chassis was printing, I would be thinking about what I already wanted to change. So there's a point where you have to say, this is fine, it's good enough, just like put it down, walk away, because no one else is going to see the problems that you think that you have in there. Take photos of your work as you go. As we were putting this presentation together, I found it very hard to like remember what I did because I didn't have enough photos to stick in here. And it was actually a fursuit construction panel where they were talking about step away from your work, just like put it down for a week, go away, come back. The biggest advances I made in this was when I just like walked away from it for a while. Because when you come back, you forget what the little minutia that you thought you needed to fix, and you just say, well, that's fine, and do something else. So version 3, its codename is Fire Hazard because it actually has 2 stacked lithium-ion batteries, which we had a very heated argument as to whether or not you're supposed to do that. It hasn't caught fire yet, but anyways, these super low-res displays are really limiting. Like, I actually want to display video. You can't display video that well on that without having someone make it for you, and I only have so much money, so I can't commission that much stuff. So I got better at thinking in 3 dimensions with version 2. Like, as I was working more with that Tinkercad, it's actually a website. It's an offshoot of Fusion 360. I actually started learning how to design this stuff from the ground up, like in 3D, without having to do it in Illustrator first. Oh, and I got a new 3D printer too, one that's big enough to actually print this thing in one go instead of like individual pieces like that first version was. So I based this one around, it's called the Manga display. I believe it's sourced just from a cell phone display. It's like a 4.9-inch 1080p LCD. It's got an HDMI port and a USB port on the side. Gives you touchscreen and 1080p. It's great. Oh, and it fits the general form factor that I was kind of going for. So you can see with this one, I kind of was doing the like make it an Illustrator and stack it method, but I was also working more to get away from hot gluing everything together. And so I have like screw holes and things were mounting correctly, and comes up pretty good. So the failure, this one really isn't a failure. I like this one. I wear this one all the time. But it might as well just be a cell phone with an X strap. I mean, it's a Raspberry Pi with a 1080p display with a battery like it's a cell phone. Good thing it didn't catch on fire. It's not actually a fire hazard. And it was 75% Illustrator, 25% Tinkercad. So I immediately then moved on and went to version 4. I saw a website where a guy had taken a CRT television one of these old Sony Watchmens and plugged a Raspberry Pi into it. And I said, I want to do that too, because I'm a child of the 80s. And with the point of all this is that without all of the previous versions leading up to this, I wouldn't have been able to do this. Literally everything is built on skills that I learned from doing all these other things and failing so many times. So the 3D design is entirely in Tinkercad this time. The thing you find about 3D printing is that there's the gravity, like things go down. So I had to print this. I had to print this little backpack onto the thing here, and it had to be printed this way because there's a cavity inside here for the battery. So all of this space had to be filled in by filler plastic. So of this, I threw away probably 80% of it. Like all of the little fin stuff there is all just trash. But plastic's cheap. It's real simple on the inside. It's just a Raspberry Pi. I got a couple of power boosts. These old TVs from the 80s needs its own battery. It's a bit of a power hog. So it has one battery for the TV, one battery for the Raspberry Pi, a power boost for each, and a whole bunch of like buck boost converters and stuff. Failure is always an option. CRTs hurt when you touch them in the wrong place. There's a 750 volt line in here that runs real close to where I need to solder a bunch of AV stuff down. And it hurts. It really hurts. It's 750 volts AC. Don't do it. And if you get close up to this, despite my best efforts, there's a lot of RF noise. Like, it is the 80s, and I'm sure this thing has degraded since then. I bought it on eBay. But it's an aesthetic. I like it. And learn to use the tools that you have. Like, this was just all soldering skills. It was 3D printing and then soldering down onto 30-year-old electronics, and like that solder melts, and I don't even know what's in the fumes that came out. Like, I felt not well after some of them. So what's next? I want to make a little tiny one. I've been trending towards very large. I want to go tiny. I just want a little thing that's like that big, that's like latches size or raster size. It just shows an image, and like you touch it and scroll through, and yeah, I have to learn code for that. I'm kind of going back to Arduinos, and I don't code, so I don't need to do that. But I got to finish version 4 first. It's actually not done. Like, this is just good enough to come to the convention. So, to summarize, I think probably all of our talks, failure is always an option. You learn more from when you fail than when you succeed. And buying tools to solve a problem will be expensive and may not even solve the problem that you're having. So just learn to use the stuff you got to the best of your ability, and then kind of move up from there if you want to. I don't know how to end presentations, so look at this GIF of me boy. And we have a couple friends who also have digital badges. We got Latch in the front row. And is Sarah here?
No, he's not. He's so it's one of my friends in Auburn took me up to Microsoft and goes, "Hey, I want to try to do this." And we started buying parts, and he used a small little 3-inch e-ink display, and it's a 3-color one. So it's all, we try and do it in about the size of just like a normal, hey, my name is badge.
Yeah, so you can see like it's a different style. You don't have to go with you can go with like a name tag style. Like, next slide.
Yeah, and what's even cooler is, so DC Furs this year did a boopable badge that is, we have down here, and I see one back there. Also, if you really want to get into it, you can do like PCB art badges. Lumi does these really awesome pins that have LEDs and lights and actually have a little ATT-6, I think, microcontroller in them. And he sells these, and he did one for TFF, he did one for Denver in 2018, and he's going to do one for FWA. So,
don't think like this is the only thing that you can do. Like,
use the fandom to.
I'd like to point out that all of us had an ideal image of what we wanted our badge to look like, and not a single one of them looks similar to each other.
Yes.
Like, I went e-paper, and this went to a CRT.
I went backwards.
Yeah, he went backwards in time.
These are our handles so you can find us on social media. If you ever have a question, you can ask us. I'm sure to respond to anything that's related to this type of tech on Twitter.
Yeah.
So does anybody have any questions? See you over there.
Can you leave that up when?
Yeah,
no, you cannot ever follow us.
Now. Anybody else have a question?
Wow, we did it. 104 slides in 64 minutes.
Is there any sort of group or place to talk
We are. We do have a small group branched out a bit, but talk to me after the Prezi.
What about other forms of input, like variable resistors and like knobs or whatever to do things to impact the images and all that?
Oh, NXS has knobs on, like you can on your CRT.
Oh well, the TV. I mean, that's built in.
And,
No, I know what you're going for. Like this one has, like this one just has a little push button on the back, so I could cycle. It doesn't work.
So
No, it might walk up. It's not
the
moving.
DC first batch has an accelerometer.
Yeah, I think this
for example.
froze.
It froze.
Yeah, so if you saw me come up and
there it
reset
goes.
it a bunch, the accelerometer thing detects if you've like put it down and forgotten about it. That's why it keeps turning off.
Okay. Yeah. So you have to consider that like there are a lot of things that you can do with it. There's like a GPS module that you can connect to your Pi if you want to be somewhere.
Yeah.
Like there's all these crazy stuff that you can do with it.
That you're looking at digital input, output, and analog digital converters in those cases. So those kind of key terms to start looking for if you want to research that more.
That in interactable animations
Yeah.
to do various other things.
My thought with making one of these was because you can buy S8s with like, broken glass
Yeah.
backs or whatever, dead batteries for like $20 now.
Yeah.
Yep. No.
Oh, totally. We've seen some.
No, no,
people, we've seen some people that do
unfortunately-
that. They just like strap a phone to their neck.
We-
That's
we-
great.
And then I
Wait.
saw them on the screen. I'm like, he beat me to it.
Yeah, we've thought about that because one of the limitations that we find is like battery power and consumption. The Pi is
Yeah.
still a power hog compared to like a phone. Like it's still a very large processor in die size, right?
Yeah.
So like if we could industrial design something to like all the negative space that is not a circuit, put a battery in it,
Yeah.
then that would be great.
Oh,
but like
yeah.
that's what these guys
But,
do,
I mean,
right?
This is the
we've
smallest
all learned
thing.
what happens when you put a big battery in the Samsung.
Yeah. You probably fry something. Honestly, that's gonna
Get the
happen.
Galaxy Note 7 as well.
Yeah.
Yeah.
Boom.
Yeah, no.
Also, that was a problem I didn't want to solve, which is why I just bought a photo frame to go apart.
Yeah.
So don't be ashamed to find something off the shelf and then rehouse it.
That's totally fine.
Because someone else had mentioned they wanted to just take a Kindle apart, and they said it felt cheap. I'm like, no, that's exactly what I did.
Yeah,
Just take it.
I've,
fine.
I've thought about like getting like the systems on these phones are called Snapdragons, most of them. I thought like, hey, can I get a system on chip with a Snapdragon and just like use it? But it draws a lot of power.
And
Power is almost always our
And also,
concern.
yes, it has that curved screen, and if you drop that,
well, there's durability issues there too, and then you have to learn. That's a different form of programming than what we do here. That's it's all Android. So it's something. It's awesome. It's idea. We go with it.
I've thought about going to Android by the way.
Yeah.
For these things.
that's honestly what I go off. That's
Yep.
what I know.
That's totally acceptable as well. Like, and then you can have fun with the coding.
Oh, fine, good, fine.
I find it funny
That's
to
all
say.
you.
Anybody else has a question?
Any other comments?
You want to come up and
You wanna
see
come up
and
and see?
Come
touch
see,
it?
touch. Thank you.
Yeah, please.
Thank you so much. We did it.
Yeah.
My favorite.